Hey there, guys. Welcome back to the channel. I'm your buddy Shaunak, and today we are about to dive deep into the realm of microservice architecture, focusing on a very crucial pattern, data ownership. What exactly data ownership means in the world of microservices, and how can you actually implement it? Understanding its significance not only facilitates seamless communication and collaboration between services, but also mitigates the risk associated with data inconsistency, redundancy, these sort of issues. Join me as we discuss the complexities of managing data in a distributed system and explore the practical strategies for ensuring ownership across services.
Alright, picture this. You have a character in a story or a movie, and they gain this amazing ability to hear absolutely everything, no matter how far away the speaker is. At first, it sounds like a dream come true, right? They can eavesdrop on secrets, detect danger, and even uncover hidden truths. And it's like having the world's most powerful pair of headphones. This newfound power quickly turns into a real challenge. You see, this character cannot turn off their super hearing. They are bombarded with sounds from each corner of the world. They become so overwhelmed by the flood of too much information. In the end, they get rid of this ability because it turns out it's actually more of a burden than and less of a superpower. Now imagine if those people were microservices. Each microservice had the ability to reach into every other service's database. This kind of setup requires extra knowledge such as database, schemas, and credentials. It leads to a deeper coupling, which becomes a very tangled mess of wires that becomes impossible to unravel. This is a problem that faces many monolithic systems. In a poorly designed system, any part of the software can potentially read or write to any part of the database. So, what happens next? Let's say you want to decide the database schema. It's like shaking a beehive. The effect can ripple across the entire system in ways that you cannot predict. But wait, it gets even worse, right? When you have a shared database used by multiple microservices, suddenly those changes are not just affecting this one code base. They might mess with multiple code bases written in different languages and deployed independently. Coordinating deployments of those changes across multiple services may also result in downtime in some of them. This can be extremely difficult to manage and makes it very hard to evolve. This is why one of the foundational principles of microservice is that one service should take charge of handling and updating its own information. To make it clearer, let's talk about something called a single writer principle, which was proposed by Martin Thompson. It's pretty straightforward. It says that data should belong to just one owner or a single execution context. Let's take this principle and apply it to microservices. The idea is to avoid having multiple services trying to change the same kind of data. When multiple services mess with the same data, it can create a lot of problems. We have to solve locking, consistency issues across all of the services. We want to avoid all these problems. Ben Stofford actually rephrases the single writer principle in his book, Designing Event Driven Systems. He suggested that it should also apply to the way we share events between microservices. Okay, these events act like an API for the microservices and therefore should be owned by that specific service. In essence, if an external service needs to access the data, it should go through an API. This API could be a REST service, it could be an event published to a PubSub platform, or even something fancier. But here is the final thing. An external service should never ever, I repeat, never ever go snooping around in your database. That's a big no no. Instead, they have to play by the rules, the API contract. This can be enforced using database permissions that restrict read and write access to the microservice by creating separate database for each microservice. Now, this has many advantages. All of the data is isolated to a single microservice. Your microservice can evolve and change internally without causing chaos for anyone else. No impact on the clients of the API. It's like redecorating your room without messing up the whole house. This also means that service has now more freedom when choosing now how the data is stored. It could mean storing events or other unusual structures. It could also mean using a totally different database, SQL, no SQL, any sort of database, even other than relational database. So these sort of freedom comes in once you move to this sort of diagram. So when it's come to making changes in the microservice, how will you do that? It's easier in regular database because we can just give our API different versions. We can introduce in a new version of the API and slowly switch over the services that depend on it. So no need to rush to make all the changes at once. Okay, somebody might consume your V2, somebody might consume your V3. So everybody need not be on the same version in order to consume your services. Okay. However, you have to be very careful to avoid unnecessary coupling through the API. To reduce code, we might be very tempted to take our database objects and present them through the API. When you do that, the basically the API becomes best friend with your database structure. And guess what? Now you cannot change your database without breaking the API and vice versa. It's like changing the wheels on a moving car. Instead, we should explicitly separate our database objects from the objects we present in the API to prevent unnecessary coupling. Now I get it. If you are used to working with a monolithic relational database, this whole data ownership things might sound like learning a new language. You might think, hey, I will miss those fancy queries that pull data from all over different places. But here in this diagram, you are gaining something even more valuable. Your code becomes easy to maintain. So you lose some complexity, but you gain a peace of mind. Okay. Finally, just be careful. It may be very tempting to build microservices that just use a monolithic database. This is something referred as a microlith. Instead of getting the best of both the world, you end up getting the worst of both the worlds. You and basically figure out that okay, now you get a tangled mess that's harder to manage it. So it's just you might say you might lose out on an awesome benefit of microservices, like having a variety of database, better maintainability, and a reduced contention. Instead of all of those things, now you just get a tangled mess that is much more harder to manage. And so it is far better to just pick one architecture and stick with it.
So there you have it, folks. A comprehensive explanation of data ownership in microservices. By understanding its importance and implementing effective strategies, we are now better equipped to build resilient and scalable systems. As you embark on your own microservice journey, remember the key principle that we have discussed today. Data ownership is not about just about assigning responsibility. It's also about supporting collaboration and maintaining data integrity across services. Thank you for joining me in this discussion. If you found this video helpful, don't forget to like, subscribe, and hit that bell icon for the notification for future content. And as always, keep coding, keep innovating, and keep pushing the boundaries of what's possible in the world of tech today. Until next time, this is Shaunak signing off.